Sorry guys about the delay. These things happens sometimes, or very often. All right. So about the interface, I'm not going to cover everything on details, but I would like to start open the program site 3D. Well, in the structure analysis, we have several programs. The ones we are going to cover today are going to be 3D, Site 3D. We are going to talk a little bit about the portal frame generator, and that's all. But at the same time, I want you to know that Site Connection is something extra that will be able to manage. Well, you can manage if you suppose you have a warehouse and you have more than 200 nuts or joints to solve, and some of them it's impossible to do it using the software. So you can come here and start working with SiteConnect, and you will be able to finish that or give any solution. Beside that, we have the bin environment, which is another in the cloud. And in the cloud, you can also have the same program Site3D, which is called Beam Site3D. It's the same thing, but in that case, that particular case, you can develop more information regarding to elements like air conditions, electricity, and all that kind of stuff. But also, we are working in a very nice software in the bin environment, which is called Bin Steel. And Bin Steel, you will be able to develop any joints you might need, any combinations, because right now what we have, I will show you, we have several options, but not enough for every joint in another connections. So this is it. So I'm going to start for the Site 3D. Just click here. We are in the version 2021E. Okay, we have four columns. The first one is the files, is where you place and save your job. The recent files, the second column. Help is something that you might need it when you are starting the software. When you learn the software, you can start with the examples. You have some documents, special user manuals, and the calculation manuals. And the last column, which is called the way to connect with the cloud, which is the Bin Server Center. All right. Now I'm connected with the Bin Server Center. This is my name, Diego Cuellar, and also on the bottom, if you click here, you will display everything in the environment. So I'm going to start with a new job. Just give it a name. Could be, example. And the browse, that browse show you where, where you're going to place perhaps this job. And also the extension is going to be .ed3. That means that you are using the Site3D. And any description. I'm not going to get involved with that. Maybe I'm going to add one number here and accept it. Okay. Well, you can start with the empty example, or if you have any IFSC files, you can start that. I'm going to do it with the empty example. So this part, I will talk about later. Accept it. Okay. So for now on, you are going to work in 3D environment. But the first thing is that if you want to introduce a node, for example, a new one, the cursor, check everything, any connections, any cross section, you can click here, and now you will see one little node here. That point, the numbers go by default. Yeah, and next ones, if I want something on top, you have this extension that give you, you can create the height of the second node in the theta direction. And every node have two conditions: the external fixicity and internal fixicity. External means that it's suppose in the future, in the near future, are going to have something connected with the soil. So that connection could be one of these options. Okay, so in this case, I'm going to introduce the fixity one. That means that displacements are fixed in x and y and theta. Also, the rotations are fixed. There are several options, and but for this case, I'm going to continue with this selection. So that's the way we right away understand that this is the fixed connection. And the one on top, if you click on top, you displace it. If you have the one bar and both sides are connected, this is the case. But if it's not, if it's not the case, you can introduce an internal fixicity. That means suppose a column, the column is connected with the soil, so maybe slab, and that's mean external fixicity. And internal fixicity is another joint on top, and that one on top also have different connections. Could be the fixed one, could be the fixed node with with partial fixicity, or maybe one that you can create in your own. So that's it. So it's a fixed node on top. And the second part is just to introduce any bar you want. So a new one. So from this place, you can create a new bar. By default, the program displayed this bar, this kind of bar. And then we have several options here. We can start with the generic ones. If perhaps you want to need the type, select this. And later on, if you need more information about this particular wave of solving the problems, you got this extra information. Also, this kind of bar has to be working in tension. It's not allowed to work. If the bar are be able to connect it in tension always, that means that the structure have a solution. And also the last two buttons, the columns and beams, recently and a few years ago, we start working inside 3D with like columns and beams in concrete. And also, you can also work with different combinations. Not only the metallic ones, you can introduce any timber, any aluminium structure, concrete as well. And what is the difference? Sometimes, people ask me, what is the difference with this concrete ones and the last two? So in these generic ones, these concrete columns or concrete bar doesn't show the reinforcements. But in the other one, the column and the beam, once you define the analysis and you finish the analysis, you will get that information. So okay, so suppose we want to continue with this kind of rolled steel sections. Over here in this button, in this grid, you have another options that there are some factories that we give you that we have an extra information regarding to all the products that they offer to you, and they post here in the program. Some of them are from Spain, some of them are from America. Um, if in the future, it depends of the people who are watching this conference, in the future, if you have any factory over there and you have the full information, you can send it to us and we can introduce it here. I'm sorry, guys. Continue with this. You just choose one of them, accept it, and you will display later that option over here. If you, once you are working and you find something, not here, maybe in the next profile. Yeah, for example, that one. It shows something in red. That's red mark means that this profile are not available for you, but doesn't mean that you cannot introduce it. You have to in this section, you can develop also any other profiles that you have already in the town, in your town, local town, and introduce it here by hand. Okay, so this is it. So I'm going to introduce the first one, this kind of profile, the IPE. Accept it. Well, I don't. This is in case you want to check the fire resistance. So then you can click from here up to here, and now you have the beam, right? So the first thing that you are going to display this over here. On this side, you have the global reference. The global reference are different from the local reference. If you click here, later, you want to display the bar, for example, you want to check to describe the bar, you will see that the reference is completely different. So you might know this thing from the beginning because sometimes that's what I'm going to show you now, the forces or the load cases scenario that we can introduce in the bar. We can introduce the joint. You can introduce any force in any joints on top and the bottom. You can introduce several options, and once you define these options, you have to make a reference. It could be the global reference or the particular reference like this one. All right, so let me show you the examples because I already had one. Okay, no, not that one. So we have now the load cases scenario. I'm going to displace all of them. We have several cases. We have the self weight, the Q1, Q2, Q3, and Q4. If I'm going to see all of them, select the view all, and we have this, right? Okay, now the scale is not good enough. Maybe it's too high. Now you go back to the load. You can modify the scales. Maybe here we can introduce 0.1, 0.1 everywhere. I'm sorry, 0.1. Let me check. 0.1. I'm going to reduce a little bit the scale, right? Accept it. Now it's okay. We're getting better. So now, just to show you how to introduce the loads in the bar, just click in the bar. You can displace all of them. So if we go back, for example, to to edit the forces on the bar, if I click here, if I click, for example, the self one, I'm sorry, I made a mistake. Let me fix it, please. Okay, that one. Okay, so we go back to the joins, edit the load case of the bar, Oh my goodness, sorry. I'm sorry, guys. Okay, going back to what we start. So I'm going to edit the load cases. Um, and perhaps what I need is to, oh my goodness, why?
It's another example, no, Diego? If it's giving you error all that.
No, I don't know why it's showing this.
Maybe you are using another standard, no? I mean, don't open all the time the same one if it doesn't work.
No, I need to show that once all. Let me finish. All right. So we have several options here. Okay, we have several options. Each of one are different. So suppose this option, for example, if I click in the load case, you will have an acceptance for key one, for example, is different location. I'm introducing any force on top of the nut is about 10 tons. The K number 2 is about 5 tons. The case 3, this is a moment. It's a flexion in the Y direction. And Q4 is another moment, but in this case is a relative location, which is in the bottom of the column. Okay, so now what I'm going to show you is how to introduce this hypothesis in the program. So we go for general information. We go back to the additional load cases. And before that, I need to create that information in the software. So we go for the live load. So I did for key 1, for key 2, and key 4. And if I'm going to displace everyone, you have extra information regarding to that. If you need it, you just displace that here. And also on the bottom, you have the combination. That combination, I can show you the combination that we are doing it. So that's the combinations and accept it. Okay, not only for that, you will see that every load that we are creating here, you can do it with wind, any condition in wind, also for earthquakes, and also for snow, soil pressure, any accidental force. So, but the basic ones are the self weight and the dead load, live load as well. In this case, I'm introducing the live load case scenario. Um, okay, now I'm going to show you another profile. Let me see. A simple beam. In a simple beam, we already have the analysis. When you display the analysis and you have color here in the icons, means the analysis is done. The first thing that I want to see in this, we go for the loads. I'm going to show the visible ones, or I'm going to show you all of them, and also the loads and you can edit, for example, key 1, the self-wet dead load, and another case. Any of them, you click in the right click of your mouse, you can display the load descriptions. This is a point load. That one is the uniform load that we're using right now. That's the apply moment. Also, we can apply an increase of temperature. The last one, an increase in variable temperature. That's what the remember when I was talking about the global reference and the local reference, you have it here. Now we are using the global axis, which is the one on the left side of the bottom. The second case is the local axis, is the bar itself. And you gotta be careful if you want to use one of them, but just to be consistent with information, continue with the global axis and we'll be okay. So when this thing is done, I can create, for example, the state limits of the bar. You click, you can check everywhere if according to the resistance. As you know, the solicitations are the reactions, the shears, and the bending. And about the deformations, we have the torsion or twist, we have the elastic deformations, and the maximum deformations. Um, this check give you in details here one by one. The only thing that are not here are the deflection. I'll show you later about that kind of deflection. Over here in the right top, to your right, you have the full report regarding to that beam. Okay, you can go around, check any normative. I will show you later about the normative. And also, for the second analysis, you can visualize the deformation of the bar. And also, I'm going to introduce the profile. I'm going to turn around a little bit, and also the scale, which is maybe I'm going to increase it by 500. And now on the bottom, you can select the combinations. Could be the sample of cases, could be the displacements, and that's all. The other ones are for different elements, but the simple case could be the set weight or the dead load, and also the light load. If you want to see really how the structure is moving, click here and you will see it right away. If everything is okay, this is one way to check if the structure behave the way we are expecting. So that's a good reference first. Then, for example, going to check for the displacements. And for the displacement, we have several combinations. In this case, we have several combinations. And I'll show you for this combination what we have. Is something like that. Beside that, we go back to the profile. And remember that I was talking about the bar, and the bar, there is something that which called the backling, the lateral backling. Lateral backling could be for this side or the other one. In this case, the lateral backling for this one is selected this way, but remember that the lateral backling for the upper flange, you must choose this distance LB, and also the spacing. If this bar are located in the rafter of the warehouse, you must be aware about the distance between the between the purlins, and that distance between the purlins is a very tricky way to introduce. For example, if you are going to use the distance between them, if the rafter is 1.5 meters on top, So you introduce, it's better to introduce that distance because that's the restriction. All right. This is a very key options that you must understand right away, especially when you are doing a warehouse and you want to check the structure properly. If you don't do so, perhaps the structure are going to be over designed and also could be cost effective in the structure. Beside that, we have the bar and also we have the limiting definitions. For example, in this case, you maybe sometimes what we gotta understand that the deflection, suppose if the beam is not very slender, it doesn't comply by deflection, and we must set up these things right away. That's the limit deflection that is doesn't show in the check uh, document that I showed you before, because this is separate. But you gotta understand that if you display this, you have some numbers by default, but I think the relative maximum deflections goes by the normative, and you must check the normative. That's just for example, as an example, if you choose L divided by 500 means that you are using walls very poor low some particular walls, but if you go for L over 400 means that you are using um, poor wall, something like that. The quality of the elements that you are going to use, you are getting exactly from the code or code reference. Normally, this limit, the relative maximum deflection, goes between L 2 by 50 or L over 300, more or less. Okay, that's the maximum deflection. So remember, is you want to check the deflections, that's the way to set up the deflection. But also, if you want to check if you want to see the checks about the bar, doesn't show you there is this result over there. So if the beam is slender means that you must check this kind of deflection first. Okay, you have an extra information in this book. You have the limited deflection here. I encourage you to read it. Now, I'm going to see the to edit the group, for example. In this group, in this site, from this point N1 and N2, you have the sequence. And for the last one, which is in free in the top, the last part, this is a tangent. The definition is a tangent, and the reference is the point number one. Point number one is this one. Okay? You gotta be careful with this. So once you run the analysis about this small beam, you can check also the element. Click here. We already did that. We already did that. Now the analysis, we go for the check element. Click here, and will displays exactly where you are. So we are using the IP 180, but it's, you can get it all lower. That means that according to the load case scenario is okay, more than okay, but also on the right side, you have the percentage of use. You gotta be careful about the weight. If you want to save money in the company, so you must go for the lower one maybe, and you will be safe. The same thing for the other bar. All right. So now we go for another example. Maybe I know. Well, I'm missing something. Now we go for forces. Here, you can see just to show you here, this part, not in here. Maybe the scale is not good. Maybe I'm going to cruise maybe one. Maybe 10. Okay, good. So now you can see the deformation. You want to do the deflections over here. If you want to check the overload, now you have the deflections. You have the stress, which has always mentioned before. Now, if you apply the first law, any force that you are applying in this in any elements, if that element has a mass, and also are you creating an acceleration or inertia in that structure. What the reaction means, the tension that you are creating that's in the bar. So that's the way to see or to check that tension in the bar. Okay. I think this is it. We can go back, to the analysis. Now maybe you might need the reactions in the bar. Click in one of them, you will see the displacements and the information regarding to that knot, the second knot, and the last one is not okay because it's not supported for any external fixicity. In this case, we are using the knot number one, external fixicity, and the second point, we are using external fixicity in the bar. And from all of them, we have different cases. For the soft weight, also for the load, dead load, you see we are having some numbers here in the reaction in zeta, and also for the light load, creating different environment. That's the way to check it. And now in the analysis, we can display also the displacements if we have that kind of displacement. Okay. The same thing we here, and for the overload, which are going to be more important. Now we're going to, I want to show you another example, which is the buckling. Okay, for the buckling, we go here bar and check the buckling. I'm going to check the buckling here. So about the buckling, it's almost the same. You can work with these coefficients. You can, as you know, the formula is L equals beta by the distance. But you can use the beta, the simple, but you must check also the coactions. Depending on the coaction, you can use the beta. If it's not the case, you can introduce the length. With the length, you can start doing the analysis. Sometimes when you are working in a warehouse, some of the laterals, or one of the laterals of the warehouse are going to be supported by different elements. Could be more than one element, one column, more than one column, but in between columns, you can start working with walls. That walls are not the way to recreate that walls is when you are using the right backlink. You don't need to in the software, you don't need to start introducing that wall here, but using this information properly, you are recreating that restriction in that direction. Okay, I think this is it. Well, the same thing. The load case for this particular uh, structure, we have several ones. We have three cases. One load in that area, one load in the center, in this point, and one load a little farther from this. So you can study what's going on with one of them, and this software is usually help you if you are a professor at the university level. Could be nice to for you to use it and try to recreate different scenarios. So the analysis is the same thing. You can check the bar, any bar. You will see the code check depending on the code. Now we are using the Eurocode. In this case, you're watching the Eurocode, but any combinations, any solicitation, any deformation that we might have, we might have here, you can check if everything is okay. If it's not okay, you will have it in red mark or in different color than green, and come here, check the reference, go to the article, read more about what is the problem, and perhaps with with this information, the extra information, you can go back and do the modification in the structure. I'm going to show you the deformation by the, for example, by the not P2, P1, which is more important. No, it doesn't, it doesn't. Let me show you more. I'm going to increase this value, 200 perhaps. Yeah, 200 is okay. By 200, so perhaps you can see it properly. I'm using just what I'm checking what is happening with this with the P1 load. P1 load is in this bar over here. It's over here. So, affecting the structure this way. I'm going to show you the second point, P2. So nothing happened, because it's over here. The P2 are affecting this part. And the last one, which is a P3, and P3 uh, a little bit, not too much. So I think the worst case scenario is the one on the corner. And that's why we can see the deflection right away. Also, you can do it by displacement, by displacements. And you have different hypotheses here. And now we can see the deformation shape. The deformation shape is really important to check if you want to see how behave the structure. Okay, now we go back here to a different case. Where's it go? Hmm. All right. So I want to show you first the plane, the dimension of that structure, which is like this. It's 6 meters. It's the same profile, but we have something different here, which is the knot in the middle. That knot in the middle create different behavior in the structure. So if you go for for the loads, for the analysis, and I check I'm going to show first the bar buckling. The buckling here this is my option right now, according to the coactions in both sides, in the plane XY plane and also in the X zeta plane. This is the option in this case. But in the second bar, even if it's the same profile, the buckling that I'm choosing is different, right? But the solutions are different as well. So now I'm going to show you the check element. Look, the difference in the code check are like this, the resistance are going to be 1.01%, which is the percentage for use. But for the second piece, we are getting different results. In the bottom, it's almost the same, but the weight changed a lot. And also on top, even the same pieces, the same element, the resistance or the percentage of weight modify a lot. So it's key important, it's very important to define properly that buckling coefficient, all right? So, um, so we go now for the tower. This is an electrical tower. Um, this electrical tower, um, sometimes it's better, to right now I'm working with the observatory, astronomical observatory, and I finished it recently. And I did it with this program, CYPE 3D. I'm not using different program, just CYPE 3D, and it's really complex, but you manage to finish the job. But in this particular case, which is really important, I'm gonna show you in 3D. It's really complex, to do it. So it's better to start the job in another software. Could be CAD program, and then you can modify the program using it or bringing this information to our software. Could be in 3D, or also you can introduce something in 2D, right? After that, we can start working with different profiles. So I'm not going to do it, but it's possible to do it. And now I'm going to show you something different, which is the load case scenario. Remember that in project and general data, we have the options about the additional load cases. So in my case, for this job, which is available for you when you display the examples, you have five wind cases. Usually, when you are doing the analysis of one wind, you have to introduce in X positive way and negative way. So here, as you can see on top, you have one direction in A, positive and negative, another direction in B, which is called B, positive and negative, and the last one, which is the wind in front of the structure of the warehouse. On the bottom, the combinations. I'm not going to show that part. And on top, we have a light load, just one case scenario, one light load. And eventually, after that, um, we can remember that we were using any load case scenarios in just one bar. You can use the bar, you can use the loads in the bar, you can use loads on the nut, and you can introduce any deflections in anywhere in the bar. That's why this example goes well when we are going to see the load case scenario. So now I can display that all the things that I showed you in the hypothesis before, you can display here all of them. I'm gonna show you just the first one. The first one goes like this because the direction, you go on the bottom, you can check the direction. It's an arrow here that show you that the wind is going from the right side to the left side. Another one, I'm going to go. Another one could be the positive one. It says a negative positive now. The positive one is different. The person who did that, they did it first. He knows the values and he did it by hand, bar by bar. The last one, maybe the one in front. That's the load in front of the warehouse. And something nice to see is the snow, the effect of the snow on top of on the roof of the warehouse. And also we have a different kind of load. We haven't talked about it. In this software, we are using just nuts, we are using bar, and also we are using sheets. And with sheets, I finished the observatory astronomic, and that I'm going to show you later. So now we can introduce a panel or a surface load. If I'm going to do a panel, I'm going to use this part here. I'm going to click here. You must select the frame. The last point you can avoid the last point clicking the right click in the button. And now the best way to introduce is, suppose that the wind is coming from the right to left, or in any direction. So it's better to show that these winds are going to displace differently. The way I'm going to study the effect of that wind in the structure is up to me. So suppose I'm going to choose this direction, and now you see any effect of this wind will be distributed in these two bars. Okay, uh, then I can start using different kind of options here. If it's a new one, I can introduce a new one, not only the one that we have as a reference, and give any value here. Okay. After that, if you run the analysis, you will see that displacements and the solicitations in that area are going to change or modify drastically. Um, then I have another option here, which is the warehouse. This warehouse is in the manual. I did in the manual. You go back here and do the example here, display the example, the 3D example. You will have this structure. It's not in there, but I did it because it's good for for it is a good example to know in a better way the software. So what I what I'm trying to show you is that in front, well, forgot to tell you that the best way to work in the software is to create windows. Windows means that in this option you are working in 3D, like you are watching right now in front, but I can create different options in 2D section about this element, this structure, and also any horizontal area. The mezzanine is this part, this part over here. This this is the mezzanine, and if I want to view it, just create the sections, and every load that I'm trying to display for you, you can see it. If it's something here, you will see it right now. Okay, that's the load that we are considering in that part. Perhaps this is the office and we have some people working there, or maybe you are going to store some materials, heavy materials, but that's the way to do it. So we go back to the windows, perhaps the vertical frame. So imagine that that's all the load case scenario, even the winds and also the dead load and light load. But remember that going back in time, and this software, when they start doing it. The way this software was called Meta 3D. Later, they changed it for Site 3D. At that time, they were thinking to solve warehouses. So they come out with something very particular about how to introduce the wind loads properly. I know it's different. If you check one of them, there are so many. There are so many here that is difficult to introduce it by hand. So the software we have an extra software which is called the particle frame generator that allowed you to introduce just the first frame like you are watching right now, and from that software you introduce all the details about the dimensions, things that are really important regarding to the load case scenario, if the people are going to work on top, if you are going to have snow, if even if the structure are going to be open, really open. Um, and then the software always as well can give you the by default the purlins define they can define the purlins according to all the information that you are introducing in the software. Beside that, give you the opportunity to take the report about that purlins separately. You don't have to introduce that purlins in the structure from now on, because you are going, once you finish, you are going to introduce the particles to the Site 3D environment. You have only the possible elements that you are going to have in Site 3D, but also from now on, you can start introducing the elements of all the profiles that are going to constitute the structure. But at the same time, what you got by default is this, all these live loads, dead loads, wind loads automatically. It's really important. Another use of this software, which is called the particle frame generator, is that if you have a marquee, for example, you have a parking lot and you want to protect the cars, and you have only one section. Suppose this is the right section you have here, the right section, just this part, in this part. So in that case, also you can use the particle frame generator and introduce the same geometry, the same size, and in both sides. Finish with the normative, finish with the code, finish with your cases, a scenario, and then once you are inside 3D, you can delete the left side of your house, delete all the light loads on the loads and wind loads in the left side, and continue the analysis about the marquee. Okay, that's another way to use the software. So I have here maybe that one. This is the particle frame generator, but it's just quick, just to show you quick, because we have only one hour, and but later you see if we arrange the possibility to show you more in details about the particle frame generator, we will do it. But now, because we have running out of time, I can show you just right away. You have to choose the new particle in the software, and then introduce the geometry of the frame that I already showed you, and then it will display like this. Then you will be able to analyze the purlins on top. Also, you can use lateral purlins, and beside that, they give you the deflections according to the limit that you already do the analysis. That deflections, remember, this is a very normal way to displace these values. L over 250 or L to over 300 is more or less the best way, the usual way. And also on the description purlins, you start with something else. You can start with these kind of profiles. Once you choose one of these buttons, the program are going to check according to the load case scenario which purlins are going to fulfill their requirements. Once it's done, you can go for the second step, which is the separation between, or the distance between purlins, and then you can create any one you might need. But the program by itself are going to check what is the best distance in between purlins. And then when you finish with a part, you give you a full report about how the profile is working in the structure, and they give you this kind of documentation as well. And then the last step is just to show which kind of options that you are going to visualize after finishing with this software. Once you are in CYPE3D, that you will be able to define if the first particle are going to work or behave the same way from the last one, or in betweens. Between particles, you can create some kind of working together. If you modify one of them, one of the elements in the middle particles are going to affect all of them. But depends, no? And I prefer to not to do so. I prefer to describe a few of the few determination about this selection. And then when you are in CYPE3D, it's pretty easy to do whatever you want. That's the case, and I have another things to show you that sometimes we forgot to talk about the how to call the interactions between software. And as you can see before, we are using the particle frame generator. And once you are inside 3D, the conventions, the wind conventions, are different in CyCAD. So does picture give you in the right side the wind combination that we have inside 3D, inside CAD, sorry, and the second one, which is this in red one, it has the combinations of the conventions that we have inside 3D. In the last case, which is called 3D interactions, that kind of a structure, we use it a lot in the program. Is a very nice way to introduce the program automatically knows or recognize that the wind solution, the wind conditions with different software are going to displace properly in when you are using both of them. So on the bottom, you have in the red color, the conventions that we have inside 3D. On the bottom, you have the convention that we have on CyCAD. But don't worry about it, because the program by itself are going automatically. Once you export that structure to CyCAD, the program recognize this convention and do the proper job. All right. Thing is this. Well, there is some difference between if you have one place, if you have the warehouse just in one level, that means that we have only one selection. But if one side of the structure have a different level, you must take care about this before going to export that in CyCAD. That's all. Okay. So one of the best way to do it is you have to select one side of the structure, fix it connected, and the other one freely. The one, for example, if I choose this part, the one here, if I choose this part freely, that means zero connection. I'll show you later. And the second part, which is the right side, will be fixed connection. And then once you are in CyCAD, you have to define that this connection has to be fixed. That's the solution. All right, so we go back for the 3D view. So you see, this very messy job is well done using the particle frame generator, and also it's pretty interesting, you know, that you have everything done in a seconds. Now just to see perhaps the check element. Well, it's gonna take time. Well, sorry guys. So we go back here. Meanwhile, the last thing that I want to tell you, to show you, is the job that I'm working with. Okay, this is the job. I'll show you in 3D. I think it's the best way. Okay, so that's the observatory, astronomical observatory, and we did it inside 3D. It's pretty nice. It's a little complex, but is possible to do so. And once you finish with this, it is called sheet. The gray color means shields, and these shields I'm going to describe the section of one of them. Is for the thickness is 4 millimeters. You want to create a new one, a new shell. You could be concrete. You can use steel. You can cold form steel. You could be also aluminium or any generic one. Okay. So I think the best way to see it, to visualize the job, is if I'm going to open what I did in PsyCAD. I'm going to close all these. Okay. All right. I think this is it. I'm going to open PsyCAD. Take a little while. Don't worry. So okay. So that the same structure, I can display that structure on top of this building. So this is one way to use the 3D interaction between structures, and it's pretty cool. And you will see all the effects. You can introduce the wind effect inside 3D, then here. I think this is it. If you have any questions, please let me know. Um, you can write something in the chat. So if you have any questions, just let me know. Okay, guys, so I guess you don't have any questions. So I'll finish the transmission. Thank you very much.